Hello everyone, in this video I will be starting solving the question papers of KSET 2020. This is a series of 6 videos in which 2 videos will be from each sector, that is inorganic, organic and physical, covering up till 96 questions. Remaining 4 questions are environmental chemistry that will be dealt together with the other papers. So on average there will be 15 to 16 questions per video. So in this, if you get any kind of queries or doubts, you can post it in the comment. I use the easiest method to explain each of the answers. If you can get much easier way is well and good, but preferably these are simplest ones which I have found. So let's start now. So now to begin with, the first question is, Mendeleev proposed the existence of unknown elements and he named this eta aluminium. So you might have all studied about the Mendel's periodic table. So in that he has predicted n number of elements which were not discovered at that point of time but later discovered. The word eta refers to next. So for this, if you know the periodic table, after aluminium we'll have gallium. So eta aluminium refers to gallium. It cannot be boron because it is pre-discovered. Silicon does not belong to the same group of aluminium, so it will not be working. In case of indanium, it wasn't known. So the answer is to be C, gallium. So in case of question 2, here they are given different cations and they are asked us to write it in increasing order of ionic radius. They are also given the atomic radius of each. To note that each element belongs to a lanthanide series and I have written them as per the increasing order of the atomic number. And as you all know, in lanthanide series we can observe lanthanide contraction, which indicates that there is a steady decrease in atomic and ionic radius. So here since in exam we are not given the ionic radius, for our understanding I have written the ionic radius of +3. So in this, cerium is having maximum and lutetium has minimum. So according to this, we will be having D as the answer. For this, you can concern the topic lanthanide contraction. Now the next question is, sulfide ion is isoelectronic too. Isoelectronic refers to the number of electrons between the molecules or the atoms should be same. Now in case of sulfide 2- we have 18 electrons. And the remaining options which are given as oxygen 2- which has 10 electrons, aluminum +3 has 10 electrons, sodium +1 has 10 electrons. Only potassium +1 has 18 electrons. Means S2- and potassium plus is having same number of electrons. That is, they are isoelectronic. In this case, K+ is the answer. Now here is the next question. Geometry of IBr2+ and Br3- respectively are. In this case, there is this is a shortcut trick. In depth, if you go, there is a long procedure to identify this, but here I will use a shortcut trick where it is given as Z is equal to V plus B ± C divided by 2. Here V is the valence electrons, B is the number of bonds formed, C is the charge. Here if the charge is negative, then that number should be added, and if the charge is positive, the number should be subtracted. So now in case of IBr+, here the central atom is iodine. So iodine has 7 valence electrons. It is forming 2 bonds with bromine, but it has 1 positive charge. So as what I mentioned, positive charge should be deducted, divided by 2. Here what we get the answer is 6 divided by 2, that is equal to 3. Sorry, it is 8 divided by 2, which is equal to 4. So 4 indicates tetrahedral. We have to see first only 2 options remain here. Now in case of Br-, we will have 7 electrons. Again 2 bonds are formed. Then there is 1 additional charge. There is 1 negative, so it should be added. Here it becomes 10 by 2, which indicates it's equal to 5. What is the 5 number indicating? It is trigonal bipyramidal. So the only option with tetragonal bipyramidal is B. So here the option is B. Now similarly we have question number 5. Here also we have the same quiz, but in case of this form, the previous method which is been mentioned, it can be only applied to the compounds which contain S and P block. In case if it is considered in D block, then you have to check with the electron splitting. Here we have NO2 minus SO2. Here we will have, similarly if you take, we will get sp2 sp2. Now the another one is MnO4 minus. In this case, if you go through a normal method, you will get sp3. But it has also been found that we have this method in which we know that manganese has plus 7. So all the D vacancies, 3D will be empty and 4s. And for this, the normal transition will not take place. It will be LMCT, that is ligand metal charge transfer. So for that reason, all the oxygen will start with 3D and 4s. Because of the gap between 4s and 4p is too high. So the bonding will form in within these two. So here there will be SD3 or D3S, sp2 sp2. So the answer is this. So now in this you have to find a bond order of NO plus, NO minus and NO. And you have to give which has a higher sequence and lower. For this you have to understand the molecular orbital theory. And you have to find a mode diagram. I have already drawn the mode diagram, so it will be easy. As you all know, nitrogen has 5 electrons in valence and oxygen has 6. If you place them fill them as per the Haber-Bosch principle, we'll get it in this sequence, where in anti-bonding we'll have 3. This is 1, 2 and 3. In case of bonding we'll have 8. So bond order is given by number of atoms in electrons in bonding minus anti-bonding divided by 2. Here it is 8. That is sigma 2s, pi 2py, pi 2pz and sigma 2px. They have total 8 electrons. But in anti-bonding we have sigma 2s star and pi pxy star. There we have 1. So total 3 electrons. So here we have 2.5. So when we consider NO plus, means 1 electron from the anti-bonding will go because it is the outermost. So it will be 8 minus 2. It will be 6. So if we divide it by 2, you will get 3. In case of NO minus, we will have 1 electron extra. So which indicates this will become 8 minus 4 divided by 2 will be 2. Now accordingly we have to put it in increasing order. So NO minus will be having the lowest value. Here NO minus is second option. After that third. So according to this, the answer should be 2B. Now the next question. This is based on the general concept on the nature of atoms. Here they have asked the most acidic in nature. Beryllium, strontium, magnesium and calcium. These all belong to the group 2. But if you observe, beryllium has more or less properties related to aluminium, which belongs to group 3. This can be explained by the diagonal relationship. You might have studied when you have studied about a periodic table that many elements of first period have properties to the elements of second period but not of the same group of the diagonal family. In case of lithium, it is that of manganese, beryllium, aluminium. So according to this, if you take manganese, calcium and strontium are highly basic. So beryllium oxide is acidic. Now in this reaction, we have to find which is Bronsted acid. So Bronsted acid concept is it should be have the ability to donate electrons or donate protons. So we have to find which are the species which can donate protons. Since it is a forward backward reaction in the same this, so in this case here it has 2 hydrogens and here it has become 1, means it has donated the electrons to this proton to this one. In case of here it is exactly reverse. So the possible Bronsted acids are 1 and 2. So that option is option C. Now, lithium nitrate on complete hydrolysis yields. This is a direct question. If you know the reaction, we can easily write. Here is the reaction. So it forms lithium hydroxide and ammonia. So next question comes to be here. So question 10 has been reported wrong, because if you want to have any reaction, there should be two reactants. But in this case, we have only one reactant and one solvent. This particular question belongs to non-aqueous solvents. If we have another compound, then this is possible belongs to acid-base neutralization reaction in non-aqueous solvents. So this question is given grace mark in 2019. So now next question is enthalpy change. So here it is based on the enthalpy change. Here they are given carbon triple bond O has enthalpy bond energy of 1074, oxygen double bond O is 499, carbon double bond O is 802. Here to find a change, you have to find what is the amount of heat produced during reactant and byproduct. So it is direct, simple. This here I have given 2 times the bond energy of this, because here we have 2 atoms, plus 1 time this. Here in case of this, we have 2 bonds of C double bond O. So it is 2 into 2. So this is a simple calculation. You can directly get the answer. So the next question is number of bond pairs and lone pairs presenting H3PO4. I have already done the structure. So number of lone bond pairs is 8. If you consider lone pair, each oxygen has 4 lone pairs, 2 lone pairs. So there are 4 oxygens, so 8. Here this comes this one. So the next question is octahedral complexes of the formula MAB CD E2, where AB and CD are unsymmetric bidentate ligands and E is a monodentate ligand. So we'll have, in this case, you have to draw all 6 structures. If you go on drawing the structure by changing the position of the ligands, it will be found that you will get 6 geometric isomers, and out of which 4 are optically active. So in this case, you have to draw all the possible structures and check which are optically active and which are geometrical isomers. So the next question is here, among the following complexes which absorbs the longest wavelength. So this question is based on spectrochemical series of ligands. So whichever is having least or we can say weak field ligands will absorb longer wavelength. So I was summarize this because we have only 4 ligands mentioned. So I have taken these 4 ligands. Otherwise, there is a full sequence of the ligands present. So you have to consider which one will work. So in this case, we have fluoride as a minimum compared to others. So in this case, fluoride is this. So in case if they give bromide, iodide, then iodide will be having the least. Now the next question is NiBr2 reacts with pH2EtP at low temperature to give red colored complex A, which on warming at 25 degree forms a green colored compound B. So the observed magnetic moment of A and B are respectively 0 and 3.2 μs. So the geometry of A and B respectively are. So one thing you have to note that they are given the geometry, what is the magnetic moment observed. In this case, they are given the initial compound as nickel bromide, means it is nickel is in +2 state. So when we consider the consider excitation, we will be having the d orbitals with 8 electrons and 4s empty. But for the first compound, he has mentioned a condition that its spin moment is 0, means indicating there should not be a free electron. So it can only be possible when this second last electron from the d gets paired up with the other unpaired electron. So they will be having 1d, 1s and 2p will be considered, which will be a square planar. So other cases we don't have square planar, so we can directly conclude on this. But in case if they are given more than one square planar on the same side, that is for geometry of A, then you have to go for tetrahedral. For that, in that case, one thing what we can do is they are given 3.2 as μs for B. So if we heat means the electron has to jump from one to next one. So in that case, there will be 2 electrons which will be free. So assuming that we can have only 3 more, and one thing you can remember, nickel will form only complex with coordination number 4, and automatically your octahedral complexes will be deleted. So similarly, last question of this set is this complex. Among these complexes, you have to select the correct order in decreasing the amount of LMCT bands. And as per when I had explained of KMN of MnO4 minus, I had mentioned LMCT, that is charge transfer from ligand to metal. Here we have a direct idea that when you have the order decrease, iodine will have the least energy, and fluorine will require the maximum energy. So only option C will have that option. So this can be explained by the size and also HSAB principle. That is, iodine is a very soft base and it easily dissociates. Similarly, when you consider size also, iodine is very bulky. So it is easy for the iodine to give up the electrons and move out compared to others. So with this, I would like to end. If you all get any kind of queries, you all can put it in my comment box, or I provided my mail ID and my Insta ID. I'll contact you as soon as possible. So thank you one and all. Please do like my video and subscribe my channel.